After 4 long months of uncertainty, tension, and scientific frustration, NASA scientists have finally received a breakthrough signal from the Voyager 1 spacecraft, restoring a glimmer of hope to the mission team that has been struggling to understand what went wrong. Since November 2023, the nearly 50-year-old spacecraft had been sending only a steady but unusable radio tone back to Earth, a signal that showed Voyager 1 was still alive and transmitting, yet contained no readable science or engineering data that could help scientists determine its health or status. For a mission that has survived cosmic radiation, deep space temperatures, extreme distances, and nearly 5 decades of travel through the harshest regions of space, this sudden loss of meaningful data was both unexpected and deeply concerning for NASA's Jet Propulsion Laboratory, who oversee the Voyager mission. The spacecraft, which has ventured farther from our planet than any human-made object in history, appeared to be functioning at the most basic level. But its inability to send comprehensible data left scientists puzzled and anxious about whether a permanent failure had occurred. Voyager 1's recent challenge revolved around its onboard computers, specifically the Flight Data Subsystem, known as the FDS. This computer is responsible for collecting, formatting, and packaging all of the spacecraft's science measurements and engineering information before sending it to Earth through the telemetry modulation unit. Although the spacecraft was still beaming out a carrier signal, which acted like a blank radio channel, the content inside that transmission was corrupted or unreadable. NASA engineers spent months attempting to diagnose the issue remotely, an extraordinary challenge given the spacecraft's enormous distance from Earth. Because Voyager 1 is more than 15 billion miles, or nearly 24 billion kilometers, away, every command sent from Earth takes approximately 22.5 hours to reach it. Then, any response or signal sent back from the spacecraft requires another 22.5 hours to travel home. This means that every attempt to troubleshoot or test something takes close to 2 full days, drastically slowing the process in ways unimaginable for modern space missions operating closer to Earth. In early March 2024, after many unsuccessful attempts to fix the corrupted data issue, the NASA team decided to try something new, a maneuver they referred to as a poke, essentially a command prompt designed to force the FDS to behave differently and possibly bypass the corrupted portion of its system. This poke, sent from Earth on March 1st, instructed the spacecraft to rely on alternate sequences in its software that could help it avoid damaged code or memory. Despite the distance and the unknowns, the mission team hoped the poke might nudge the spacecraft into providing some sort of meaningful response that could reveal more about what was happening inside the failing computer subsystem. 2 days later, on March 3rd, engineers on Earth detected something unusual, a signal from Voyager 1 that differed from the unreadable data stream they had been receiving for months. This new activity suggested that at least one section of the FDS was responding differently than before and might be attempting to send coherent information. It was not immediately clear what the signal meant or whether it contained anything useful, but the mere fact that it had changed gave the team new energy and revived hope. Over the next several days, NASA engineers worked tirelessly to decode the strange new transmission. This was no easy task. It required deep knowledge of the spacecraft's architecture, decades-old documentation, and careful analysis of data patterns that had not been seen in years. By March 10th, after days of analysis and decoding, the engineering team finally realized what the spacecraft had sent, a complete readout of the FDS memory. This was a massive achievement, especially considering the spacecraft's age and distance. The readout included the software instructions the FDS uses to operate, the values and variables that can change depending on commands sent from Earth or the spacecraft's internal conditions, and even locations in memory where science or engineering data is stored. Essentially, NASA had received a map of the FDS's current state, which could be compared to previous memory readouts to identify exactly what part of the system had malfunctioned back in November. This development marked the most promising step forward since the communication issues began. With this memory dump, NASA scientists now had the ability to trace the problem to a specific section of code, a corrupted memory cell, or a malfunctioning circuit, though identifying the issue would still take time. engineers must now compare the recently received memory profile to older versions stored in NASA's archives to look for inconsistencies that could explain the corrupted data stream. Because the spacecraft is so old, much of its technology is outdated by modern standards. The 1’s, for example, runs on hardware with memory measured in kilobytes rather than the gigabytes or terabytes of today. With such limited memory and slow data transmission rates, every bit of information matters. Voyager 1's remarkable longevity is what makes its problems complicated, but also what makes this mission so important. Launched in 1977 alongside its twin spacecraft Voyager 2, Voyager 1 was initially sent to explore Jupiter and Saturn, completing a historic mission that revealed volcanic activity on Jupiter's moon Io, intricate details about Saturn's rings, and new insights into the outer planet's atmospheres and magnetic fields. After completing its primary mission, Voyager 1 continued on a trajectory that carried it through the outer regions of the solar system. In 2012, it became the first human-made object to enter interstellar space, crossing the boundary where the solar wind from the sun is no longer dominant. Since then, it has been providing invaluable data about the space between stars, known as the interstellar medium, helping scientists understand cosmic radiation, magnetic fields, and the environment outside the protective bubble of the heliosphere. The spacecraft's journey is a testament to human engineering, creativity, and determination. Yet at nearly 5 decades old, it has far surpassed its expected lifespan. Its systems were designed in an era before modern computers and digital communication existed in their current forms. Much of its technology is no longer manufactured, and the engineers who originally worked on it have long since retired. Diagnosing problems from billions of miles away without the ability to physically repair or replace parts requires extraordinary ingenuity. Engineers must often come up with solutions that involve reconfiguring old hardware, rewriting decades-old code, or repurposing systems that were never meant to perform certain functions. Now that NASA has successfully recovered the 1’s memory readout, the mission team is entering a new phase of investigation. They must carefully examine the readout for discrepancies, changes, or corrupted values that weren't present before the issue began in November. If they identify something that has changed unexpectedly, they may be able to patch or rewrite the affected section of memory. However, doing so will be extremely delicate. Any command sent to Voyager 1 must be precise, because sending a faulty or incorrect command could disrupt other parts of the system or make the situation worse. And with a long communication delay of more than 45 hours for every round-trip message, trial and error approaches are slow and risky. NASA has emphasized that although the new signal is a major breakthrough, it does not guarantee a full solution. The spacecraft's age means there could be other failures waiting to occur, and the 1’s issue itself may involve permanent hardware damage that cannot be repaired remotely. Even if the memory comparison reveals the exact location of the problem, it might not be possible to fix it. There is also the possibility that the corruption could spread or worsen over time. Still, the mission team remains optimistic because Voyager 1 has survived numerous technical issues throughout its lifetime, including memory glitches, power drops, radiation damage, and communication challenges. And each time, NASA engineers have found creative ways to work around them. The real significance of this breakthrough is not just the data itself, but what it represents. Proof that Voyager 1 can still respond to commands, process new instructions, and send back meaningful information. This means the spacecraft is far from dead, and the mission still has a chance to continue. For scientists who have spent decades studying interstellar space using Voyager's instruments, keeping the spacecraft alive for as long as possible remains a top priority. The data it sends cannot be replicated by any other mission currently in space, and the unique position it holds, more than 15 billion miles away, makes it an irreplaceable scientific tool.